Here. All right. Scott and Corey, we're ready to roll.
Okay. Well, good evening, ladies and gentlemen.
What? It shows how many people are just watching. Yeah. Unless they comment or something.
Okay. Good evening, ladies and gentlemen. Tonight, Scott and I are going to do a presentation for you, a demo of culmination of 9 months worth of turning on Sundays so that we could try to figure out how to do a multi-axis piece on the exterior of a bowl on a 3-point bowl. Now, 2 years ago, Scott and I went to the AAW symposium down in Chattanooga. One of the featured turners down there was a lady by the name of Barbara Dill, who has been mentioned here a couple of times tonight. And just a sidebar comment to that, she has been invited to be the international demonstrator at the Irish Woodturner Symposium, I believe in October of this year. So she's going to be sharing that information with our Irish Woodturner friends. So anyway, we came home from that, and a lot of this multi-axis turning that we talk about and do is based off of having your cylinder on top and bottom, and then moving off your X and Y axes at a certain prescribed distance, and you can end up with nice twists and spirals and things like that in your piece of wood. That's all based off of a gauge that Barbara uses that divides that cylinder and its tenon into 120 degrees. All right. So then one night I couldn't sleep and I thought to myself, wait a minute, if the cylinder multi-axis turning is at 120 degrees and we take a 3-point bowl, which we had here as a demo for what yeah, a couple of months ago. Then that was all based off of the 3 points on this bowl are at 120 degrees also. So then if you go back and you do a tenon where you figure out where your 120 degrees are on the bottom and you match it exactly to the point 1 to point 1, point 2 to point 2, and point 3 to point 3, then you're going to end up with being able to take off of here this material here in between your points and create a ridge with the multi-axis turning. This is significantly easier to say than it is to do. Somewhere in the mix of all of this, we can tell you a lot of things about turning exterior multi-axis stuff on a bowl, which we don't know of anybody else that does this kind of thing because they're not crazy enough, I guess, or something. But what we wanted, we were never satisfied with any of the pieces because they weren't quite as deep as we wanted them to be. They weren't nearly as pronounced. You can see the ridge coming up from the base of the bowl up to the point, and it's not quite there on some of them, and some of them they are. Tonight, we can tell you everything you shouldn't do to try to do this kind of project. And what we would also like to ask is that those of you who want to think about this and take it a little bit further, we'd love to see what you have come up with, because we had to, we worked with regular bowl gouges and we worked with all kinds of different stuff trying to figure out how in the world do you get, especially when the bowl has been turned totally round and then you want to put this flat on here to create that ridge. You've got this always coming around and thumping and moving your tool back. So we had a huge problem until we developed a jig and fixture for it, which we'll show you in a little bit, on how to keep your tool tight against the tool rest and not be bumping back with the piece of wood. We had thought about we even turned some of these, and we thought, well, we'll go to Scott's shop and we'll mount them on the metal lathe, and we will then have set the drive and the distance and the depth and all of that, except his metal lathe wouldn't take the piece this big or bigger. Okay, so we had that problem, and that's what led us to create a jig and a fixture to do these things. We also found that the more we did this, the tighter our tolerances had to be. I mean, we would cut a block of wood, and if we were off two uh, 2 mils on one side and 2 mils on the next one and 2 mils down here, it would throw the whole thing out. Okay, so we had to get really, really, really precise. The other thing is that when we started working on these things, we realized too that a lot of people will just take the step center out, pop this corner in the headstock, pop this corner into the tailstock, and turn a 3-point bolt. And you really can't see if they're exactly on 120 or not. When you start to add the turning to the exterior, you start to see those points are changing all the time. And so that led us to having to do very, very precise pieces of wood. And also then we also had to figure out how to, when I cut this corner off, I have to have it exactly parallel on this corner, which
If we deviate ever, I'm gonna exaggerate with my arms here. If one side is just a subtle deviation, 2 mil, 2 mil, 2 mil, taper, whichever,
yeah,
throw us off.
the whole thing was out. So we found that the more precise we could be, the better off we were, which took a whole lot more time to prep our wood blocks and our wood pieces in order to do this. Okay. And then the other thing that we found is that we started out using the traditional 4-spur center. But by the time you do a piece,
Yeah,
that one, this one, this one, this one,
both of these.
okay.
We get all.
Anyway, yeah. The 4-spur center, because of the way it's constructed, is always pushing as you move that 4-spur center into your piece of wood. It's actually a taper, and it's pushing your wood away. And we lost, and this would be center, and then you'd have points 1, 2, and 3 on this, and those are all coming apart and weakening the wood fiber. And I don't know how many pieces we lost. None of it, neither one of us was hit in the process of making this demo. Yeah, scared the bejesus out of us a bunch of times. But yeah, we didn't get hit. So all of that coming together, we finally found that the step center, the way it's spring loaded and the serration in the front of it really fit better because you were just pushing it into the wood. You weren't actually spreading that wood fiber out. And there you have.
Showing a little bit of the
Yeah.
3 bites
Yeah.
there compared to what was before.
Yeah. We had, I had some time ago acquired a very, very small, must have been maybe 3/8 of an inch or less 4-spur center. And we tried that, and that just chewed up the wood. Just so we finally ended up with this one that's a 7/8. And then there's one bigger than this or something. I don't know.
Yeah.
Yeah. There's 7/8, and then there's a 1 1/4 or something like. We found that the 1 inch for what we were trying to do worked probably the best for us. And even though, and that was the other thing with, we go to press this corner on. Front one. We don't have. We do. Yeah, this. As careful as we were being in trying to get this piece on the headstock, you'll still see that one side of it, of the step center, is deeper than the other side. We could never quite.
That's because these sides being unparalleled.
Get them 100% light, but these didn't slip on us. The traditional force per center was always slipping on us, and we were chewing up wood like no tomorrow. We found that we had pretty good luck with walnut. We had pretty good luck with Osage, and then I think that other piece is a piece of spalted maple.
Yeah.
Those seem to work the best. Softer wood like this, this is a Western cedar. Man, we chew this stuff up just no time, and it would be falling off.
We tried some pine laminated because we're running out of lumber. That didn't work.
The laminates didn't work very well at all, because in trying to avoid as much as we possibly could having too many of these sides being ingrained, in trying to put them together so we had as little ingrain out there as possible, we actually found ourselves having more ingrain, which as that's coming around, the traditional wood turning tools coming around, where one side was getting so chewed up, one side was nice and smooth, and the other one was somewhere in between.
Which direction is you go?
Well, we've also thought about how to take a log and how we would mill that log so that all the end grain was coming out of the front of the bowl, right? When you're all done. Oh, that'd be beautiful. Yeah.
Yeah.
If we could get end grain running like this, but right now my grain's running like that. And so even we were thinking of how to take a log, how to mill it, and so you would have perfect end grain going vertical.
Yeah.
And we never got back to that idea.
Yeah.
But
that's another one.
that was, constantly how we're gonna. So when it gets to this, the frustration of cutting it, being offset, and then when we even have to find the center in here, like this Osage, we would measure our flat here, find half of that, and then take it right up to the next point. Half of that flat, take it up that point. Half of that flat, take it up that point. Find center, and then we would offset it from there. That is as accurate as we were thinking we could be at that time. And so that's where we are at that.
How did you make your cut to get them?
Okay. For the first 8, we were doing this, holding this, and that was tricky, holding like this, and Cory's caught. Then, a little flatboard knowledge, you just tilt the table of your bandsaw 45, okay, and you take your miter's,
that thing.
miter gauge, you set that at 45, boom, boom, and then you can run it across the bandsaw. And if you have a very rigid bandsaw blade, it'll cut nice and straight, and then you just flip it 180 and cut the other one nice and straight. If you have a rigid bandsaw blade, but it's got a little craftsman, it's got a little flex to it. It goes like that, just a little bit, just ever so subtle. Subtle enough that when you do this, you don't get a solid bite all around it. And so that's an offset point. And so that throws you off. And then after you've machined it down, perhaps the thicknesses of your wings are offset, or one wing is even lower because you were offset. So that from the very beginning, we have the opportunity for error to grow and grow and grow and compound. And it did that a few times. In that sample that we handed around, that is a faux profile that we were looking for. If I could use the phrase proof of concept, our proof of concept is all these others here, okay?
Yeah.
I did that with a rasp and everything because I was like, this is what we want, but it's not what we were getting. We're getting these very subtle profiles. It just wasn't turning out the way we thought it was going to turn out last January. Okay?
Yeah, we mentioned your name in the shop a lot, Cody.
Yeah, proof of concept.
What we're looking for is just proof of concept. That's all we're looking for.
And we feel we met it.
Yeah. Yeah.
And so now we'd like to show a little bit of how we set it up in this high dollar tool chair that we manufactured, and
they are for sale in the lobby for $29.95.
yes.
I think
Whoa, but wait, you can call now. You can get two.
get racing.
Yeah,
They have an online bidder.
Uh-oh.
seriously. Oh. Here, you want to
Yeah. Okay. So
that? I'll talk about the tool.
I'll talk about the issue we were having as it's coming around in the offset, having a tool, we just have a. So as it's coming around, boom, 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 boom. And I'm really holding it, trying to keep it nice and steady. And then the edges of the profile would start down here and be zigzagging all the way up because I'm getting bumped around, right?
Can't move.
And so how do we stop that? How do we control that? And that's where I thought my milling machine, my metal lathe would be great because I had auto feed and everything, just hit the lever and drink coffee and right? Small machine, didn't have much room for a big block of wood to swing around. So then we came up with something like this. Okay. And it fits mine better than it fits his. So I don't have mine with me. The idea was I want to be able to lean into this and it ain't going to get bumped, right? And it ain't going to go no farther than this stop right here. I was trying to come up with an auto feed, and with these two here being different, my adjustable feed screw here, 1/4 threads, right? And so the concept of this is when this one's locked down, and adjust that screw and pull this in, so then I could feed it in precisely a certain amount for the next cut. And so once I got one profile cut where I was giving it a nice clean cut and the profile was coming up to the edge, then I would stop and it'd be set for the next saw. So all I have to do is rotate the wood and everything's set. You leave your banjo set and everything's set. You just work your way back up to that as a depth. So it was a depth stop, coming up with a depth stop. I hadn't seen that before except in the tenon cutter, right? Which is very similar to this thing, except it's all one piece. This was two pieces. It didn't quite work out like I thought. Okay. As in the adjustment. I figured a 1/4, one full turn, 50 thousandths. That was what I was shooting for minute feed adjustments. But this was giving it a very bad finish. Yeah. So we tried a carbide, just scraping it along, and that gave it a bad finish. And
then we said, hey, wait a minute, what's causing the bad finish is that we've got that point coming out there and the bevel, front bevel area. So why don't we get rid of the bevel? Okay. So we came up with, and I already had this, what I guess in this day and age they refer to as a bottom feeder tool, or a tool that has nearly, I think we've got about 99% bevel on there. And we found that that worked probably as well as anything, that the wood would hit and then be cutting off instead of moving that tip back. So we put this on here, and that seemed to help us tremendously. Okay.
What do you make your little rig out of?
That's proprietary material, sir.
We're bound by patents that we know. Seriously, a few years ago, I had taken a metal spinning class, and part of the tuition paid for this. This is a high density nylon type plastic. What they use it for, I have no idea, but I had a chunk of this in my box of metal spinning tools. And then we said, well, this one needs to be stationary and this one needs to be able to adjust. And so we kind of came up with that idea. And that was not the most successful thing we did either. So that's what we had. I did find a company down in Texas, and all they deal with is plastics, and all they deal with, and this is a high grade nylon for whatever, I don't remember what they said it was for, but you can buy it by the foot, and you can buy it from 2 inches to 6. Huh?
Delrin?
I think so. Delrin or Zelon or something like that. There were a couple of different ones depending on what your application was. And since ours was going to be making a jig for turning, they didn't really have anything. But they do have, gosh, they had square blocks, they had rods, they had all kinds of stuff down there. And they can ship it out, but we didn't need it. We only made the one. So
Later, though, I think they would work well.
yeah, yeah.
Hmm.
Yeah, they set us up an account and they could have shipped in 24 hours. Anything that we needed. But they were very helpful, and we read a lot online about the different plastics and nylons and plastic nylons and all kinds of things, and so that's what we came up with because we had it. Okay. Any questions so far? Yes.
So for the different curves on the outside, you're changing your axis from moving parallel. You're doing one of these.
What we found is that if we wanted to do a twist on here, it was just we couldn't quite get the mechanics for that. So we stayed true to 1 to 1, 2 to 2, and so yes, we're running parallel. Yeah.
So, both sides are then shifted up somewhere down.
Yes, yeah. And we generally, just because we were doing it that way, we would start with 0.1 and we would turn on 0.1 till we thought we had that little bit of a ridge. And to be honest with you, it isn't until you get over into side 3 that you really start to see the ridges in it. Okay. So your first cut is like, yeah, okay. And then you kind of start to see the ridge between points 1 and 2 coming together when you're doing the second side. But the points really are evident or kind of evident when you go 3 to 3. What we had started to do was, according to what we were reading in multi-axis turning, is that you would start with a 1 to 2, 2 to 3, 3 to 1. And that should have given us that spiral twist, 120-degree angles, and a 60% twist. And
So you could start at the bottom, have your subtle line go up and land in between.
yeah,
Or start in between and have it go up and land at the point.
yeah,
Challenge you guys to try that.
yeah. That we found
That would be neat to do.
more difficult than anything else, trying to achieve that twist on there. So that's why we went back to parallels. And we seem to, what limited success we had with this project, we found that to be the better way to go. And you just needed to be very aware, like on this one, where your points are and where they're going to be and which one gets numbered what. And you always got to stay true to that. There's no variation on a theme there. And we found that no matter how we tried to mount it, no matter how precise we got, no matter what we did, we couldn't get that twist there. And that's what we initially wanted to do, was that from the bottom,
So
yeah, go ahead.
did your outside first and
Yes.
then come back
Yes.
center
Uh-huh.
to do the inside?
Yeah, we would have done all of that work on the outside here, and then
Create a tenant.
yeah, when we're putting the sides on here, it's mounted in this fashion. Okay. And then we would kind of reverse chuck it, and then we'd hollow this out like that.
So kind of going off of that question, the wood coming down and trying to do one side is not going to tool out.
Yeah.
Would it not to tool out of the way if it didn't have as much mass as it would have, if you would have say hollowed out cutting the 3 sides, just one left side, hollowed out the whole thing, and then back and do the finish outside, would that have?
We don't have center.
Yeah, if we would have hollowed it out, then we'd have
You wouldn't
to leave something down in there.
take the circle like
Yeah.
a piece of wood, put it in there,
Yeah.
and try and like match it up, and then you can still draw from the points you have.
Yeah.
That precise at the beginning because you're going off of the points that you have at the end.
Yeah.
And then can find your center and remark. Like I don't know if that was
Yeah.
getting you anything.
The other thing is that in our attempt to get the outside the way we wanted it to be, to be very pronounced and very obvious, we didn't want to, we thought to leave the mass in there so we didn't get vibration on our tips and points out here. Yeah, that we wanted to make sure that at some point in time, if and when this got hollowed out, that we would have a consistent wall edge here. And if we were taking this material down and this one was a little bit wider, but this one was a little bit thinner, we were afraid of going through the side. And so that's why we kind of left that internal stuff, this wood to the very last to excavate it, because we knew from past experience of turning 3-point bowls, this was easy. Okay, all we had to do is chuck this up, and boom, we're ready to rock and roll. And you could put your life center back up here, which didn't matter where it hit, and we would have, be able to take out a third or half of this before we had to disturb our tailstock. And so we knew we had good support. We knew we wanted to continue to give as much stability to this as possible. And there was one of them, I think, that hitting on the end grain, we got kind of chewed up here at doing the exterior, but the interior came out without difficulty.
And you leave your tailstock out fully and then move it in and then chew around it and then chew that tenon down.
Yeah.
Move it in again, chew around the outside.
Yep.
So
We tried to leave the tailstock in for as long as we possibly could. Yeah. And then when we got ready to do like this one and take the tenon off the bottom here, as we put a mandrel chuck in here and then brought this up, and we could then work on the bottom and feel like we had total support.
I was doing the experiment with it, but what speed did you find worked the best for you moving outside the bar?
We generally ran about 700 to 800 RPMs. When we first put the pieces on, they were essentially kind of okay, and then we would speed up. We never went up much higher than that because we seemed to be getting a pretty good cut over some of the other cuts that we did. And we'd start out slow and keep working our way up. And so I would say we averaged 700-800 somewhere in there.
I took your dial electric. I think his dial's 6 or 7. So
yeah, we went
speeds.
Yeah, we went as far as we could on belt number 1. Okay. Yeah. And I don't know, would we have been more successful if we'd shifted over and exceeded 1,000 or whatever? Don't know. But that's what we did. Seems like we should have had a bit more results, but some of them blew up, and there's still more of these around, and some of these are going to end up becoming where just go back and round them up again, do the exterior, take a couple cuts off, and make 3-point wells out of it.
At least have points for the first there.
Yeah. Well, thank you. Yeah, it was one of those things that Scott and I, for quite a while now, we'll do breakfast together, and then we go to my shop, and we would all through breakfast we're talking about this. Oh, I have this thought, and that kind of thing, and that would lead us on. And we got great support from guys over in Mount Zion too, who were helping out Sam and John, Bob, and helping us think about this. This was, all the time we're doing work and thinking about this, and I'm glad we could at least bring this much to you. Now, yes, sir.
Try shoe scraping?
Yeah, we did. And whatever ridges we had on there, we generally would shear scrape off then at that point, you know? So we couldn't get the shear scraper to just hit the areas we wanted. We needed to,
Was there any obscenities shouted during all these 9 months?
what we did is we chose the obscenity of the week and used it frequently. Yes. Yeah. But, it was like we'd be working and then all of a sudden this front point would shear off and the piece would go flying. And then that's it. We're done. We're done. We're out here.
More patience than I had.
Well, we didn't know where we were going, and the other thing is, if you look at the Barbadil book, it says specifically on it axis turn or multi-axis turning for spindles. Okay, and we said, well, nobody's ever done bowl that we know of, that we've ever heard of or ever seen. I don't know if anybody's ever done it. I'd like to, if you know of someone who's done this, I'd love to talk with them about it. Because we went as far as we think we can go, and now we need input from the club to you guys to try it out, see if it works for you, and figure out how we can get a more pronounced edge on it.
What I'm gonna do is, I got this set up on one of our numbers there. I let about a 1/2 inch of this tool overhang, and it is a bottom scraper. So what I'm doing now is just kind of giving myself some room to feed into it. Cut this first side, and may have to adjust this again after cutting the first side. It'll profile the edges beyond the points. Okay, and then when I cut the second side, it'll bring 2 of them together. Let's see if I can get my speed going first.
Now, do you usually rough them out close to the bowl?
We would rough them out. We would, in this process, we'd cut the square, cut the corners off, take a moment, get our points, set it between center and in the original center, and we would machine the bottom around, leaving sometimes very subtle flats, so there's enough material left. And then we'll put it in this position right here, and we'll do the 3 offsets. And also, while it's on the original center, we put a tenon on there so we can come back to that and grip onto that. So the plan now is to just show you guys a subtle profile on all 3 sides. Let's see if I can get a little cut there. There's about 600. I got a little vibration. Okay, not even touching. There we go. What's that?
Are you riding that short bevel or are you in a scraper?
I'm taking it straight in like a scraper, I suppose, and it's given a better finish because it's not as pointy as before. I also like the pencil actually. I don't know.
Indeed. The other thing we did think shot straight pencil iron. Another piece of the cut along the slide, so that I had got the machine.
way more time than we had.
So we ended up with a dado, cut the dado in 2 pieces of wood,
Uh-huh.
glue them together,
And then glue them on,
scrape or screw
and
it
then
together.
screw coming down, hold it before. Didn't think of that.
That's just what I thought real quick.
Yeah,
Oh, you got a good thought?
yeah,
Write that down?
yeah.
Your head's in with it.
So, different.
We could,
Thank you. Real quick, can you see it pushing me out? Because we weren't quite parallel, don't have 100% contact over there. All right, so my cut is starting right about here, and it's ending right about there. Not even getting to the point yet. Not even getting to the point. So I see a line right here, kind of like my profile line. And can't really tell where it's at over here, someplace like that. So it's not really straight yet. Really straight yet. So instead of moving that, I'm actually moving the banjo in ever so subtly. This tool, like the tenon forming cutting tool, does anyone have that tool by chance or ever use that type of tool? You know, I'm talking about the Robert Sorby. It's got a little hook on it. That, okay.
So I have much success.
Much. Okay. The idea is similar to that.
yeah.
Okay, I can see I'm still cutting. Still need to remove more down here to even get this one side completely flat.
Now I notice you're using a single point on your live center. You'd be better, safer if you were using the cup center. Point with the
Ooh,
cup.
do you think a cup would be better? Yeah. Yeah. More surface contact than a point.
Okay.
Right. Step center would be good. Yeah.
Rotating
Mm-hmm.
live tails.
Let's do some of the syrup.
Yeah.
Yeah.
Good suggestion. Good suggestion.
Dog on one side. That life.
Wow. Feels like I can go a little faster, maybe. No, not really. No. Yeah, hold her down, man. I'm gonna sit up here. Yeah. Woo. Now, this is another situation where we've had it tear out so much up here that we had to scrap the piece. It's spun on me twice now. I'm gonna make one more cut, then I'll flip to another side, show you that, and we can get two of these matched up. That'd be great. Am I heading away? Okay. I'm beyond this edge here. I think I'm beyond that edge there, so I'm going to switch my points to a different point. What are you doing? Come right there. Yep. Wow. No, got to take it in quite a bit. Oh, yeah, go. Okay. I'll try to do it. Okay. Okay. From the bottom. So without moving anything, once I feed this all the way in to this handy dandy tool stop, I should be at the same depth as the previous cut. The trick is not to jam it all the way in there right off the bat. All right. I can see a profile here. This one's all over the place. And so I got a little bit more to machine down here on this edge here. Take a little bit more. I keep seeing this stop on me. Okay.
Is your rest too high?
Now?
You were angling down there.
Well, here's another thing. With this, it's nice to, I want it to be perfectly horizontal, and sometimes I'll work it side to side to get the cut. But did it look like I was dipping?
It looked like you were looking up right when you got that last catch.
Okay.
So, Scott or Cory, how would it be if instead of doing your 3-point bowl to begin with and doing it all around, what if you did this step to start with?
Mm-hmm.
So start your square block with it being offset the 3 different times.
With roughing it out round first, allowed us to remove a lot of material on a real concentric surface. And so that when we did offset it, it's less material to remove than starting from the beginning and working your way all the way down to that level. It's a whole lot more material to remove on the offset. Yeah. Once we tighten this.
We need to have this action.
It just doesn't seem to want to get tight.
See the amount of airput. There it is.
That's why I thought a cup center better.
Yeah.
What area?
You have a step son on it?
Yeah.
Let's swap out.
Stop right here.
Okay.
Wow, yeah, that's an hour.
Mm.
Some other people really want them, but it's not a rotation.
Oh, no.
No,
It's not a rotating glide setting.
Okay. Then I don't want to. Oh, we're gonna have to stick with this. I'm look at that. I'm holding that and I'm spinning it. I don't think I can get enough effort. Enough.
So that weight is pushed in, it's spread the wood.
Yeah.
He's fired up, that might.
Yep.
okay.
Let me take one more set of cuts and then we'll see how this turns out. If it keeps slipping on me, we're gonna stop
Yeah.
for safety reasons. Yeah.
Any other questions? So far?
How about this? Can you think of anything else this could be used for besides this offset turning? A jig like this on your tool to control a depth of cut.
It,
If you had a curved tool rail and was doing a spare, that would, you can set your
Yep.
continuous rate in.
Okay. And follow that around. That's a good idea. Yeah.
We also though, just to go along with that, when we were trying to do this side, we did put a curved rest on there. And it didn't work any better or any worse than a straight one to do this.
For this, but for yeah.
Exactly. Yeah, you would have control all the way.
Let me make one more try.
I think we're somewhere around a quarter of an inch. We tried it at one point more, and that was not working towards it. We found if we kept it a little bit closer, it would work better. And we started with sevens, and we were trying 7-inch cubes, and then we ruined a bunch of those. So then we thought, well, okay, let's try a 6-inch cube, and basically we were trying to find material that we could get that out of, and then we finally settled on a 5-inch cube because we had material without having to laminate.
That's what I.
Yeah, yeah.
5s or 6s? 5s. Okay.
I like.
Yeah.
Yeah.
Material was a big issue for us trying to find solid material. I had some large bowl blanks I cut out a log a year ago, but when I cut them smaller, guess what? They still had moisture in them and they dried and we got some cracks like this. So we'd do that. But ladies and gentlemen, this was what we tried to do. This very subtle profile on a 3-point bowl. We spent a lot of time doing this and struggling through some of the issues. It was fun most of the time. And looking forward to getting caught up with all the other demonstrations you guys done this year. I want to catch up and do some projects that you've done.
Yeah.
But
Just an FYI, it's a lot of fun Sunday.
yeah, there was.
Yeah, I know, but we knew this was coming up and we weren't far enough along on it. Let me see. We finally decided last Sunday, enough is enough.
Yeah.
Let's get our tools together. Let's get our somewhat of a success and a whole lot of failures. And let's just go in and do this and draw from the,
It was very interesting.
Wow.
and it's something that we had a good time with. I read it.
Was it or?
I'm not sure. Not sure. I think we need some time away from it.
Yeah.
I'm looking forward to doing a run-of-the-mill ordinary bowl and a
Yeah.
platter,
Yeah.
that I can just stand there and it happens, and then go sharpen and come out and do it again. But we had a good time with this, I have to say, and I think we pushed our limits and our knowledge and our experience to the level to at least get that little bit. And so we have proof of concept,
Proof of
and
concept.
we were happy to get that.
So, thanks, guys.
Yeah. See, you guys want to do that? Yeah,
Yeah.
mark us down.
Because then
Yeah.
everyone will go to the other demonstrations.
Yeah.
And so set it up so
Well, we had hopes that this was not going to turn out well for us tonight, and that you would ask us never to come back.
So Barbara Bill didn't have anything for you guys?
We learned the basic